All right, you asked about the hardest problem, I think, in the book, and so we have to solve it because you asked, right? I put up here a bunch of formulas we're going to use. These are right off the formula sheet. I swapped out some x's and y's so we don't get them confused with the a's and b's in our formula. But the first thing we're going to do here is we have a cosine times a cosine, and we have a formula for cosine times cosine. So I'm going to use that to get 1/2 times the cosine of, and when I add those two pieces together, the b's will subtract out to 0, leaving behind 2 alpha, plus the cosine of, and when I subtract those two pieces, the alpha subtract out, and beta minus negative beta is positive 2 beta. And then from here, we can use our double angle formula. Cosine of 2x is cosine squared minus sine squared. So now I have 1/2 of cosine squared of 2 alpha. Oops, I'm sorry, just 1 alpha. Minus sine squared of 1 alpha. That splits up the first one. The second one, that was a terrible bracket, basically came into those two terms. The second one becomes a positive cosine squared of beta minus the sine squared of beta. That's splitting the cosine up into the two terms. From here, we've got a lot of sine squareds and cosine squareds, which we can use our power reduction formulas. And now we have 1/2 times 1 minus the cosine of 2 alpha. I'm sorry, it's a plus on the cosine, plus over 2, minus the sine, which is 1 minus cosine of 2 alpha over 2, plus the cosine squared, which becomes 1 plus the cosine of 2 alpha over 2, minus sine squared, which is 1 minus sine squared of 2 alpha. Whoops, nope, that's not right at all. 1 minus cosine of 2 beta. Whoops, the other one was a beta 2 over 2. There we go. So fixing my things, we were doing beta, so it has to be beta. Sine becomes 1 minus cosine of 2 beta. Everything's good there. Another thing I would do is with these subtractions, I would distribute the negative through the following fraction. That's going to make it easier to combine like terms because they're all over 2. So I'm going to combine the alphas and combine the betas together to see what we end up with. And when I do that, we get 1/2 times 1 minus 1 is 0. Cosine plus cosine is 2 cosine of 2 alpha over 2. Plus 1 minus 1 is 0. So I have the 2 cosine of 2 beta over 2. And then the 2's reduce out. And I'm going to also distribute the 1/2 through. So I've got cosine of 2 alpha over 2 plus the cosine of 2 beta over 2. And what I notice is we've got cosine of a double angle over 2. It looks a lot like the sine squared and the cosine squared formulas. Not quite there, but very, very similar. So what I'm going to do is notice, this is kind of the tricky part. If I were to divide both parts by 2, we would have 1/2 minus cosine of 2x over 2. Same thing on the other formula. That would be 1/2 plus cosine of 2x over 2. And so they're very similar. In fact, with the beta, we want to have sine squared. They're off by a negative. So if I had a negative times 1/2 plus the cosine. Well, let's play with it actually. Let's go down here and play a bit. So what I'm going to do is I'm going to get a 1/2 in there. I can add 1/2 if I also subtract 1/2. Because I put 1/2 in and I take 1/2 out, and that gets me these 1/2s I want from my formula. So when I do that, since we have a common denominator, we've got 1 plus the cosine of 2 alpha over 2, plus a negative 1 plus cosine of 2 beta over 2. Now that's not quite what I want. The first one is. The first one is the cosine of alpha, cosine squared of alpha. That's good. The other one, though, we've got the wrong signs. And so what I'm going to do is I'm going to factor out a -1. Which actually makes me realize I wrote the problem down wrong as I'm looking up. That should have been a minus in the original problem. I wrote the problem down wrong. That's what I get for moving too quick. So let me erase the plus. It was a minus in the problem, which now works because I'm going to factor out that -1. So I have 1 plus cosine of 2 alpha over 2. Factoring out the -1 gives us 1 minus cosine of 2 beta over 2. And then we can finally celebrate 1 plus 2 cosine 2, 1 plus cosine of 2 alpha over 2. That's the power reduction formula. That's cosine squared of alpha minus this one here is sine squared of beta, QED. It was ugly. It was a lot of work. This is probably the hardest problem in the entire set, but we did it. Let me know if you watched this all the way to the end. I might be able to give you some extra credit points for following through all the way to the end. Send me a message. Let me know you watched it, and I'd be excited to see that you did.